Introduction to Statistics, Chapter 11, Inferences on Two Samples, Section 11.3, Inference about two means independent samples. Requirements for running a hypothesis test regarding difference between two means independent samples. First, the samples are obtained using simple random sampling or through a completely randomized experiment with two levels of treatment. The samples are independent. The populations from which the samples are drawn are normally distributed, or the sample sizes are large, greater than or equal to 30. For each sample, the sample size is no more than 5% of the population size. Okay, those four requirements must be met to run a hypothesis test. Now, running a hypothesis, classical approach. Okay, first, determine the null and alternate hypothesis. Now, left-tailed test. First, we assume there is no difference in the means, so mu1 equals mu2. For a left-tailed test, we're trying to show that sample 1 has a smaller mean than sample 2, so mu1 less than mu2. Since this is the case, if you go back to the null hypothesis, if mu1 equals mu2, then mu1 minus mu2 will equal 0. This is an alternate approach for writing the null hypothesis. And for the alternate hypothesis, if mu1 is less than mu2, then mu1 minus mu2 is going to be a negative number, which means it's less than 0. Okay? And the form on the right is what is used in StatCrunch. The form on the left is what's usually written in a document. Right-tailed test, null would be mu1 equals mu2. The alternate would be mu1 greater than mu2. For a two-tailed test, we assume mu1 equals mu2, and we try to show mu1 not equal to mu2. That would be your alternate. Level of significance would be the same as what we've been doing. 1%, 5%, 10%, or some other value given. Compute the test statistic. In this case, it would be x bar 1 minus x bar 2. Minus mu1 minus mu2. Well, if we assume mu1 equals mu2, then mu1 minus mu2 is 0. So this could actually just be x bar 1 minus x bar 2 over the square root of standard deviation of sample 1 squared divided by the size of sample 1 plus the standard deviation of sample 2 squared divided by the size of sample 2. Sketch the curve for the test. The curve would be the same as what we've been doing. But now, since we have two samples, you're going to use the smaller of n1 minus 1 or n2 minus 1 for your degrees of freedom. Okay? So a lot of times both samples have the same size, but if they are different sizes, you take the smaller 1 minus 1 for your degrees of freedom when you find your critical value. Then you compare the test statistic with the critical value to see if the test statistic is in the critical region. Now write a conclusion, which is the same. All of this is the same as what we did in Chapter 10. Now, p-value approach, same thing. You set up the null alternate hypothesis, left-tailed, right-tailed, two-tailed, the same way as you did for the classical approach. Select the level of significance the same way. It's usually given. Compute the test statistic, same formula. Now you would find the p-value using a table or StatCrunch. Well, we know that if we run a hypothesis test in StatCrunch, it gives us the test statistic and it gives us the p-value. So there's no need to worry about the formula for the test statistic or how to find the p-value using a table. Okay. Now compare the test p-value with alpha. This is important. You need to remember, this is the same case as Chapter 10. If p-value is less than alpha, reject the null hypothesis. If p-value is greater than alpha, fail to reject the null hypothesis. And then write your conclusion, which is the same as we've been doing. All right, now using StatCrunch to run a hypothesis test regarding difference between two means when given the data. If you're given the data, you're going to click the icon to open the data in StatCrunch. Then you're going to click Stat on the top menu, highlight T-Stats, highlight two samples, click with data. Select the column that contains the data for sample 1. Select the column that contains the data for sample 2. Click circle beside hypothesis test for mu1 minus mu2. Enter a 0 for mu1 minus mu2 value. Choose correct inequality sign, less than for left-tailed, greater than for right-tailed, not equal for two-tailed test. And then click compute. Okay, that's when you're given the data. Now, when you're given the means and standard deviations of the samples, okay, this time you would just click the question help at the top right of the problem to open StatCrunch. Click Stat in the top menu, highlight T-Stats, highlight to sample, click with summary. Enter values for sample 1, the sample mean, sample standard deviation, sample size, X bar 1, S1, N1. And then do the same thing for sample 2, X bar 2, S2, N2. Click circle beside hypothesis test. Enter 0 for mu1 minus mu2. Choose correct inequality sign, less than, greater than, not equal to. Click compute. Okay. Now, let me look at a problem. So if we go to your homework for this section, here's a homework problem for this section. Okay. This is problem number 4. Test whether mu1 less than mu2 at the alpha equals 0.01 level of significance for the sample data shown in the accompanying table. Assume that the populations are normally distributed. Now, if I click on the, first off, let's look at the null and alternate hypothesis. Well, we always start off with mu1 equals mu2. Up in the problem, it said we wanted to test whether mu1 is less than mu2. So that's going to be your alternate. So the null is equals, the alternate is less than. So let's see, it looks like it's going to be down here at D. The null is mu1 equals mu2, the alternate is mu1 less than mu2. That's what we're trying to prove. So that would be that. Now, the next thing, this could be a little misleading because it says the sample data shown in the accompanying table. Okay, if you click on the icon to open up the table, this is not a set of data. These are the results for population 1, population 2. Okay, so you have the N, which is 33, X bar 103.5, S 12.3 for population 1. And you have this. So in this case, you are actually giving the summary. You're given the data, the information. So we would click the box up here. Let me shrink this down here a second and put it on the left side. Now I'm going to open up StatCrunch, pull it out, click it to the right. Okay. Now I'm going to hit Stat, T-Stats, to sample with summary. Okay. And now sample 1 has a mean of 33, no, mean of 103.5. Be careful, these aren't always given in the right order. Standard deviation 12.3, and the sample size was 33. Now, the sample mean was 114.5 in the second one. Standard deviation was 13.3. And the size of the second sample was 25. We're going to do a hypothesis test, and we're trying to do what? Less than, so I want to choose less than. Okay? Compute. And I can come over here and close this now because I already have the data. So it says determine the p-value. Well, my p-value over here was 0.0011, and it says 3 decimal places. So 3 decimal places, 0.001. Check your answer. We're good. Now, state the appropriate conclusion. Well, since the p-value is less than our alpha was 0.01, our p-value is 0.001, which is less. Since it's less than, we're going to reject. So we look at reject, reject. And now what do you have to remember? if you reject, there is enough evidence. So this says is not, this says is, so this is the one we want, C. Check it. Okay, next question. Now, let me go down here to question 7. Okay, now this time, question 7 gives us a data set. Okay, this is a set of data. So, let me enlarge this a second. All right, so the researcher wanted to determine if carpeted or uncarpeted rooms contain more bacteria. The table shows the results for the number of bacteria per cubic foot for both types of rooms. A normal probability plot and box plot indicate that the data are approximately normally distributed with no outliers. Do carpeted rooms have more bacteria than uncarpeted rooms at the alpha equals 0.05 level of significance? Okay, now, so what's our null and alternate hypothesis? Well, remember, we're going to check what? We're checking that do carpeted rooms have more bacteria than uncarpeted? So I'm going to let my first one be carpeted. Okay, so this will be carpeted. Okay, and now the next one, remember, it's always equals. And then we would do the, whoops, let me go back here. I wanted to mean. I threw one in here, and mean of no carpet. Okay? Versus, now I'm trying to show that, what? Carpeted rooms have more bacteria, so the mean of the carpeted is greater than the mean of the uncarpeted rooms. Okay, so you have to be able to read the problem and interpret into the null hypothesis, knowing which one comes first, which one comes second. So carpeted was my sample 1, uncarpeted was sample 2. All right, now let me shrink this back down, pin it to the left side. Now I'm going to open my data in StatCrunch. I'm going to pin it to the right side. Now, in this case, I'm going to go under Stat, T-Stats, to sample with data this time. And my sample 1 was the carpeted, and my sample 2 was uncarpeted. Okay? I'm running a hypothesis test. I'm assuming no difference equals, and I'm trying to show that mu1 is greater than mu2. That was for my alternate. Okay? Now, I guess I'm ahead of the game because I didn't check this answer. So let me check this answer. Fantastic. So I want to calculate the test statistic T0. So that's when I ran this test. Compute. So T0 is the T-stat to 2 decimal places. So that looks like that's going to be 1.66. Check your answer. And now find the critical value. Select the correct choice below. Okay, now, since we are looking for greater than, okay, then we're just going to look for T of alpha divided by just T sub alpha, because we're only looking for the right tail. And alpha was 0.05. So if I go to this table for student distribution, now, I know that it's 5% in the right tail, so I'm going to use this column right here, the 5% in the right tail. But now, degrees of freedom, okay, if you notice, degrees of freedom, they both had 8 sets of carpet. Okay, so it doesn't matter which one I choose, so 8 minus 1 is 7. So the degrees of freedom would be 7. So it's 5% in the right tail and 7 for degrees of freedom. So if I come over here, it's 1.895. And how many decimal places does it want? 3 decimals. 1.895. Yes. So it's 1.895. That came from the table. Now, if we look at this, T0 was 1.66. this is 1.895. Remember, this is your critical value, okay? If you're outside, beyond that critical value, you're in the critical region, so you would reject. If you're not beyond that point, you would fail to reject. Well, if you look at 1.66, it's going to come before 1.895. So it's going to be fail to reject. So, do carpeted rooms have more bacteria than uncarpeted rooms? Level significance? Answer would be, well, you're going to fail to reject, so you can't say it does have more. So you're going to say no because the test is not in the critical region, which I just explained. Okay? So we check. Okay? And there's a couple problems using the information we've been talking about. All right? Now, if we go back to this, now we're going to talk about finding confidence interval for difference of means. Okay, so it's going to be x bar 1 minus x bar 2 minus the margin of error, x bar 1 minus x bar 2 plus the margin of error. Margin of error is going to equal that formula. Now, to find the critical t value, use the smaller of n1 minus 1 and n2 minus 1. Remember that. Lower bound, upper bound, these are the same things we've been dealing with all along. And remember, to find that margin of error, E, the margin of error, you could take the upper limit minus the smaller limit and divide by 2. That would give you the margin of error. Now, using StatCrunch to find it. When given data, okay, well, you're going to open the data in StatCrunch. You're going to highlight to sample, click data, select the columns containing sample 1, column containing sample 2. Click circle beside confidence interval, enter your desired level of confidence. And see, now step 1 comes in. Okay? And if you're, when given the means and standard deviations, then you just click the question help and open StatCrunch, and then click that should be to sample with summary. Enter sample 1, enter sample 2. So this up here should be 2 sample, not 1 sample. And then click circle beside confidence interval, enter your desired level of confidence, click compute. Okay, so if I go in here to the homework, let's see if there's any for computing a confidence interval. Here's one. So if I open this up, random sample of 40 adults with no children under age of 18 years results in a mean daily leisure time of 5.7 hours with a standard deviation of 2.35 hours. A random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.49 hours with a standard deviation of 1.71 hours. Construct and interpret a 90% confidence interval for the mean difference in leisure time between two adults with no children. So, the 90% confidence interval. So what we would do, we're given the summary. We know the means and the standard deviations. So let me shrink this down, pin it to the left, and let me open up StatCrunch. Pull it out of my window, pin it to the right. Now, I'd click Stat, T-Stats, 2 samples with summary. So, sample 1, the mean was 5.75. The standard deviation was 2.35. The sample size was 40. For sample 2, the mean was 4.49. The standard deviation was 1.71. Sample size was 40 again. And I want to click confidence interval, and I wanted a 90%, so I change this 95 to 90. Click compute. Now, 2 decimal places. So the lower end up here is going to be 0.49. And the upper limit is 2.03. Okay. So now we have our confidence interval. So we check it, we're good. Now, continue. This brings me to the next thing that I'm going to talk about in the PowerPoint, which we've talked about. How can we use this interval to check whether there is a difference in leisure time? Well, remember, when we check the interval, we check to see whether the interval contains 0 or does not contain 0. If the interval does contain 0, we fail to reject. Okay? If the interval does not contain 0, then we reject. In this case, the interval does not contain 0, so we reject. So, there is 90% confidence that the difference of the means is in the interval. Conclude that there is significant difference in the number of leisure hours. Conclude, and all of these down here. There is a 90% probability the difference of the means is in the interval. Conclude that there is significant difference in the number of leisure hours. Well, if you were trying to prove a difference, you would want to reject that there is no difference. So in this case, I'm going to say it's going to be D. The way he has it worded, it's different than what I would normally see worded. Oh, no. Now conclude that there is significant difference. So if I look at A and I look at D, there wasn't a whole lot of difference. Oh, the difference is down here in the last one it said probability. Up here it says confidence. Okay, so we're looking at confidence. All right, so it got me with the words that time. And I'm sure you've been gotten a few times with the words also. So you just got to read it very carefully, because I was just skimming through this and I said conclude that there is significant difference in the number of leisure. Yes. But he put in the word probability and the word confidence. And A and D were basically the same. The difference was confidence, because we're doing a confidence interval. Okay, so that's a little bit of how to use that. Now let me go back to the PowerPoint. And that's exactly what we just did. Showing that, you know, if zero was not in the interval, you know, confidence interval contains 0, do not reject. So that would mean there wasn't evidence to show that it's different. But in this case, our interval did not contain 0, so we reject and conclude there is a difference. That's what I did in the last problem. And this brings us to the end of 11.3 and the end of chapter 11.